Hey there, we are working on this Visa card problem from the homework, and this one has a lot of people scratching their heads too. So let's break it down and think about what clues we're given. We are going to need to translate a clue in here and follow the directions in order to get started. So as we're going through, we're given two different categories of ages and two different categories of credit card use. Either they use it or they don't. And one of the first things it says in here is to create a probability table. So I'm going to do that, and believe me, it will simplify things quite a bit. So we have these two age brackets, 18 to 24 and 25 or older. And then we also have credit card usage that yes, they use it. I'm going to just put Y for that, or no, they don't use it. And I'm going to create a table here. Oops. Let me do that. And we're going to have, let's think about what everything is in our table. So we have this section right in here. Hopefully you remember that those are going to be your joint probabilities, also known as your intersections between, like for this one, this would be your intersection between 18 to 24 years old, and yes, they use a credit card. And then everything on these outer boundaries, these are all your marginal probabilities. And we know that this value plus this value will equal 1. And we know that this value plus this value will equal 1. The way that we get this value is we just add up this and this. Likewise, to get this value, we add up this and this. So that's going to help you quite a bit as you're creating your table. So let's go through our clues. We have 3 clues here. The first one is that 11% of the consumer population is 18 to 24 years old. So ask yourself, is that marginal or is that a joint probability? And hopefully you're able to recognize that that 11% doesn't have anything to do with whether they use a card or not, that really that is going to be a marginal probability. So we can go ahead and add or put our 0.11 over here for 18 to 24 years old. The second clue that we have is that the probability that a consumer uses a plastic card when making a purchase is 0.75. So I'm using this Y or N, so yes, they use a card. Does this 0.75 have anything to do with whether they are 18 to 24 or 25 or older? No, it doesn't. This is going to be a marginal probability as well. So I'm going to go ahead and plug this number in right here. So we have these values. We know that this column will equal 1 and this row will equal 1. So you can actually go in and you can start filling in some numbers here. But we're going to need to know what these numbers are in here. And so this third clue, given that the consumer uses a plastic card, there's a 0.09 probability that the consumer is 29 years old. So there's a really common assumption that, okay, I'm going to go to my 18 to 24 years old and go to my Y column that yes, they use a card, and I'm going to put in 0.09 here. And if you do that, you wouldn't be the only one that's done that, but that's not right, folks. That is not what you want to do there. So I'm going to erase that. And we're going to go back and look at this really carefully and see if there are any clue words that should alert us that we're going to be thinking about this in a different way. Hopefully by now you are picking up on the fact that we have this word given. And anytime you see the word given or like a contingency phrase that starts with if is another way. So given that the consumer uses a plastic card, it could have been if the consumer uses a plastic card. So okay, that means that we are dealing with conditional probability. Conditional probability is the one that has that line in there. Hopefully that looks familiar. And the big thing here is to remember that that line is a stand-in for the word given. So as you're reading this, it's PA given B. Our formula is going to be, and this is something you have to memorize, the intersection of A and B divided by whatever is in that B position, divided by your P of B. So let's put this into context for our clue. So given that the consumer uses a plastic card, so what that's telling me is, I'm going to get a different color here, actually get like blue. So my probability, I'm going to put my given line here. Given that they use a plastic card, so given, yes, they use a plastic card. There's a 0.09 probability, oh, that's telling me what this equals. That the consumer is 18 to 24 years old. So this is my A. So 18 to 24, given, yes. So now we can think about this in terms of our formula. So we've got our intersection of that divided by our probability of yes, and this equals 0.09. Well, we look over here, 18 to 24, and yes, we don't have a value for that. Okay, so move down to the next one, the probability of yes. Well, we do have a value for that. So I'm going to erase this right here, and I'm just going to plug in that actual number. So hopefully you see here that we have enough information that we can do some reverse calculating, just do some algebra to figure out what value this will be. And so once you do that, you'll be able to fill in this number right here. And once you fill in that number, you're going to be able to calculate this and this, because you can think about this plus this equals 0.75, this plus this equals 0.11. Once you calculate this, you'll be able to calculate this. And you've already calculated these, or you can. So your table is complete now. You've unlocked everything in your table. So now we're going to move down into these questions. If a consumer were selected at random, what's the probability that they're 18 to 24 years old? So if, that means that this is going to be in my B position. Actually, okay, I take it back. Okay, in this particular instance, that's not the case. Got ahead of myself. If a consumer were selected at random, that just means that this is a random selection. So what's the probability that they were 18 to 24 years old and did not use a plastic card when making their purchase? So for that, we have a clue word of and. And what does and clue us into? And hopefully this will make you think of either intersection or union. And once you determine if this is an intersection or a union, you'll be able to move forward with that. And actually, so your and is going to be your intersection. So what that's saying is your intersection between 18 to 24 and yes, if they use a plastic card. And so really you don't have to do any calculating here, folks. You just go up to your table and you pull the information from there. Okay? So let's move down here. Given that the consumer is 18 to 24 years old, what's the probability that they use a card? Okay, given. Hopefully that made you realize that we're dealing with our conditional probability. So let's go ahead and break this down. I'm just going to create my spaces like this. Given, if this is my given line, whatever comes directly after the word given is going to go in this position. So 18 to 24. And what's the probability they use plastic? So yes, they use plastic. So you've got your problem set up. Now you can go through, work your calculation, and get your answer. Likewise, on this one, you're told, given. So think about this. Set your problem up. The consumer's 25 years or older. Where is that going to go in this notation? And that they do not use a plastic card. Where will that go in the notation? And so once you get that set up, then you can use this formula over here to get your answer. So hopefully that helps. Have fun with that.